Hi everyone, in this video lecture, I would like to explain jet transform, which must be used for digital signal processing. Before that, you should know one thing. So, in digital signal processing, what are the topics involved mainly that are jet transform, system realization, digital filter design. So, now we go for jet transform. I'm trying to complete entire syllabus regarding of jet transform, inverse, and ROC in a single video. So let's start. If natural available signals, continuous time signals, which is like a x of t. If we are dealing x of t continuous time signal, we go for continuous Fourier transform and we are using Laplace transform. If we are dealing discrete time signals x of n type of signals, then we go for discrete Fourier transforms or jet transform. So yeah, for the first of all, why we need use transformation means the naturally available continuous time signals are need to convert them into frequency domain to understand and to analysis of any LTI systems or spectrum of respective signals, so that we are using some tools like a Fourier transform and Laplace transform, whatever it is. Signal is x of t, then we are using continuous Fourier transform. That is, the formula is Fourier transform of x of t is equal to minus infinity to infinity x of t e power minus j omega t dt. And in case the signal in the form of x of n are discrete form, then we are applying discrete Fourier transform. So that is the formula for discrete Fourier transform of x of n is equal to summation of n equal to minus infinity infinity x of n e power minus j omega n. If you want to convert them into frequency domain, we are using Fourier transform and Laplace transform. If it is x of n or discrete format, if you want to observe the frequency domain, we go for a discrete Fourier transform and a jet transform. See, though we are using Fourier transform, why we go for Laplace? You should understand that. If there is a signal and if we need to find out what is the spectrum of signal, definitely we go for Fourier transform. If Fourier transform is not possible, then we cannot judge there is no spectrum for that signal without checking Laplace transform. If again Laplace transform also not occurring, then we can calculate it. There is no frequency domain for that signal. So x of t e power minus j omega. That means you are observing imaginary part only. What about real part? So if you observe the Laplace transform, there is s is equal to what is called like sigma plus j omega. So here a real part at the same time imaginary part. So the combining of real and imaginary part called a Laplace transform. That is the reason we can define it as like the complex form of a continuous time Fourier transform is called a Laplace transform. So same we go if we are observe the discrete Fourier transform, we are using discrete Fourier transform, but it is only about imaginary part. Then what about real part? So that's the reason we go for jet transform. jet transform so what is jet transform? Let's see. So of course the definition of jet transform is also called the complex form of discrete Fourier transform is called a jet transform. So let's move. I will explain my handwriting notes. This is the so already I had told that if you are dealing with a continuous time LTI system, we analysis, then you go for continuous Fourier transform or Laplace transform. If you are going to analysis discrete LTI system, then we go for discrete Fourier transform or jet transform. So what is jet transform? So this is a difference between continuous and discrete signals. Of course, you know very well. So let's start jet transform. Of course, there is another form is called a alternate to discrete Fourier transform. This jet transform is used for only discrete time signals to convert the frequency domain. See, Fourier transform of x of t is equal to minus infinity to infinity x of t e power minus j omega t. It is a for continuous time signal. This is a discrete Fourier transform. Discrete Fourier transform means for x of n is equal to summation of n equal to minus infinity to infinity x of n e power minus j omega n. So by using this discrete Fourier transform, we can define the jet transform. Here, I would like to explain three topics. What is jet transform, inverse, and at the same time relation between Fourier transform and jet transform. So consider a discrete Fourier transform. Now, what is jet transform? Here I explaining derivation of jet transform. Okay. So Fourier transform of x of n is equal to n equal to minus infinity infinity x of n e power minus j omega n. X of n e power j omega. You can write this equation like this. Okay. After that, put z is equal to e power j omega. So instead of e power j omega, we put z. Then how it becomes like summation n equal to minus infinity to infinity x of n z power minus n. So what is the meaning of this? That means z transform of x of n. Okay, this is a z transform of x of n. X of z. It's very simple. So z transform of x of n is equal to x of z. So that means n equal to minus infinity x of n z power minus n. This is z transform. Okay. So let's move another thing. If we put z is equal to r into e power j, it is a polar form where r is called a radius and e power j omega. Then x of z is equal to minus n equal to minus infinity infinity x of n r into e power j omega power n minus n. So you can expand them like this, and x of z is equal to d of t x of n r power minus n. Okay. So the compare this equation with discrete Fourier transform. What is the meaning of this? This is like, see, discrete Fourier transform of x of n and r power minus n. Okay, this is the relation between discrete Fourier transform and jet transform. See, okay. So inverse jet transform. So let's consider x of z is equal to discrete Fourier transform of x of n into r power minus n. So where z is equal to r into e power j omega is equal to Fourier transform x of n, Fourier transform of x of n into r power minus n. Okay. So just for a transform, just keep a back side or move it left side, it becomes like an inverse. So finally, what is the formula for inverse Fourier transform formula? See right side. This is x of Fourier inverse Fourier transform of x of omega. It is also in the form of x of omega, right? So that it is also omega domain. So then you can apply this formula 1 by 2 pi minus infinity infinity x of omega e power j omega. This is a positive j omega t, j omega t b omega. So same formula is substituted here, x of n r power minus n, this term x of n, and this is 1 by 2 pi minus infinity infinity x of r e power j omega and d omega. You can write with this. You just uh, you just pause the video and observe entire derivation. So this is the formula for inverse Fourier transform, right? Advantages of jet transform. See, jet transform convert the difference equation of discrete time of systems into linear algebraic equation so that analysis become easy and simple. Okay. See, by using jet transform, we are converting them into jet domain, right? So differential equations are difference equations. You should understand that difference equation is nothing but x of n minus 1, x of n minus 2, y of n minus 1 plus y of n minus 2 plus y of n minus 3. This is called a difference equation. Differential equation is nothing but dy of t by dt, dx of t by dt. This is called a differential equation. So you should know the difference between difference equation and differential equation. So by using jet transform, we convert the difference equation of a discrete time system into linear algebraic equation so that the analysis of LPI system is very simple. In time domain, it is too difficult to convolute any two signals. So if you convert them into frequency domain, we can easily simply uh, multiply them uh, multiply them if we want to convolute the signals. So jet transform exists for most of the signal for which discrete time Fourier transform does not exist. Discrete Fourier transform. So this is the third point. Limitation. What is the drawback is frequency domain response cannot be achieved and cannot be plotted. This is the major thing you should know. In Laplace transform or some other Fourier transform, you can plot the signal and you can observe by using plotted. But in jet transform, we cannot plot it. But why we are using jet transform is to design the digital filters. So what is the formula for jet transform? Jet transform of x of n. If the signal is in the form of x of n, n domain or time domain, discrete time signals, if you apply the Z transform, what is the formula means? Summation of n equal to minus infinity to infinity and x of n z power minus n. This is the formula. So let's see some Z transform for fundamental signals. If you consider unit impulse sequence, okay, x of n is equal to del of n. Any signal, any frequency domain of impulse signal is 1, as like Z transform also 1, but how it is like, let's see del of n. So one thing we should remember that if you want to find out any Z transform, we should know that functional representation and graphical representation. This is a functional representation of del of n. This is a graphical representation. See, functional representation 1 for n equal to 0, 0 at n not equal to 0. And functional representation is n equal to 0. At n equal to 0, that value amplitude will like 1 or unit impulse. If it is unit impulse, 1, otherwise it has some value. So other except these values, except these point, everywhere the del of n becomes like a 0. Okay, so what is a Z transform such a signal? So then you just replace x of n with the del of n and expand them. Del of minus 2, what is the value of del of minus 2? Is 0. Del of minus 1, 0. Del of 0 value 1, and z power 0 is 1. So except this value, everywhere we get a value 0. So the x of z is equal to 1. Del of n Z transform is 1. So this is conclusion. So after that, unit step response. What is the Z transform for unit step sequence? X of n is equal to u of n. And functional representation, u of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. And this is a of graphical representation. At 0 to infinity, the value is like a 1 equally maintained, but left side sequence will become like a 0. So what is a Z transform? X of z is equal to z of x of n is equal to, and z of u of n is equal to n equal to minus infinity to infinity u of n z power minus n. So after that, while solving Z transform, everyone should know one thing, that is geometric series formulas. So infinity geometric series n equal to 0 to infinity a power n is equal to 1 by 1 minus a. So this is a important formula for to solve the Z transform problems. And what is a finite geometric series? If it is finite geometric series, the formula for a finite geometric series is n equal to 0 to n minus 1. This is a finite value a power n, then 1 minus a power n by 1 by 1 minus a, 1 minus a. And okay, this is a. Okay, and if a equal to what? A equal to 1, then n equal to 0 to n minus 1 a power n is equal to n. This is the formula for finite geometric series and infinite geometry. Most probably we are using this formula, a power n equal to 1 by 1 minus a. So while solving Z transform, while solving Z transform, you should know one thing, that is regarding of Z transform, you always try to make them in the form of a power n. Okay, you in n equal to e power minus infinity to infinity u of n z by z power minus n, n equal to 0 to infinity z power minus 1 power n. Okay, and just replace u of n is nothing but 1, a remaining z power minus n. So I just keep the power n by putting minus 1 here. So then what is the formula for it? Is in the form of a power n, right? So then 1 by 1 minus z inverse. So this is the formula for impulse in further problems, to in further solving complex messy problems. We should use this formula. Okay, so go for ramp signal also, you just pause it and solve it. This is r of n is equal to n for n greater than or equal to 0, 0 for n less than 0, and to like this is a graphical representation. So this is r of n z power minus n, n equal to 0 to infinity n z power minus n, and you just expand them. 0 plus 1 into z inverse, plus 2 into z power minus 2 plus 3 into z power cube, like this. And you observe there's some for series formula is equal to a r plus 2 a r square plus 3 a r cube. If you take a r as a common, then a plus 2 r power 1 plus 3 r square, then what is the sum of series formula? S is equal to a r by 1 by r square. So here a equal to 1 by, you just observe this sequence with this sequence, compare it. and you can get the values a equal to 1 and r equal to z power minus 1. Then what is the formula? That a r, that means z power minus 1 by 1 minus z power minus 1 whole square. This is the ramp signal z transform. Okay, so it is very important. Exponential sequence x of n is equal to e power minus j omega n, as told earlier. Okay, always try to make them as a power n. Okay, so this is x of n equal to minus infinity x of n z power minus n. This is the z transform formula, and put it instead of x of n e power j omega and u of n equal to minus infinity infinity a power minus j omega and u of n z power minus n. And we know that the left side sequence is becomes 0 and right side sequence is 1 u of n when it is multiplied with u of n, 0 to infinity e power minus j omega n z power minus n. So what I want to try a power n. So then how can it is possible? So just you just common, you can common n, put it as a power z power minus 1 e power j omega n power 1. So this is look like a power n. So then this is very wrong. Okay, this a power n nothing but 1 by 1 minus a, 1 by 1 minus a. So this is sorry, what it is, exponential problem. Okay, same like sine omega n. You do these problems, and this is pause it and answer it. Cos omega n. This is the z transform all about. So region of convergency. Let's see region of convergency. Of course, in Laplace transform also we know the region of convergency. So region of convergency is nothing but the value of z transform is finite. First of all, 2 points you should know: that the value of z transform is finite, the region of where the z transform is exists. So ROC, there are some properties. ROC is the z transform is indicated as a circle containing a unit circle. This is the first point. And the second point, if x of n is a right-sided sequence, if the x of n is right-sided sequence, then we then all finite values of z for which z greater than r will be in ROC. That means outside of the circle. If the x of n is left-sided sequence, then uh, that ROC is becomes like inside of the circle. And if both the inside and outside, I mean both the right side and the left side sequences signals, such type of signals, then we can draw the ROC like this. So that means this is like inside and inside of the circle, this is outside of the circle. Let's see one of the problem. This is a power n u of n, that means 2 power n u of n plus 3 power n u of minus n minus 1. See the one, see, if you draw ROC of any problem, 2 points, major things we need to discuss. That is, first thing is the circle with what radius. First thing is the circle with what radius, and where, second is where should we region, where should we shaded, shaded inside or outside or what it is. So how can it is means, first of all, given problem you should observe that 2 power n is u of n. That means u of n is nothing but right-sided sequence. U of n is nothing but right-sided sequence. That means you know very well, before solving the problems, you come to know that yes, this ROC is a outside of the circle. And here u of minus n minus 1 means, that means left side sequence. That means you came to know that, that means inside of the circle, the ROC is inside of the circle, but you don't know that point is what radius. Okay, that thing, but that thing only by solving only you get the answer. That is, so you just convert them into jet transform. What is the jet transform of 2 power n? Already you observed that in unit step problem. You just see that that's the, what is the formula for this? Z by z minus 2. Here also z by z minus 3. So what is the radius? Z means nothing but r into e power j omega n, right? Here the real part is 0, so that means r is radius, r equal to 2, so radius is 2. So you just draw the circle with radius 2. Okay, and here also same, another circle, draw a circle with radius 3. So then uh, these are the two circles. After that For this circle, the ROC is where exist means greater than 2. That means outside of the circle. You just shaded outside of the circle like this, like this, like this. So, but what about z minus 3? So this is another circle. This is inside of the circle. So finally, what we came to know that ROC is region of convergence existing between 2 and 3. This is the final ROC of this problem. We will solve the problems and pause it and note down these three properties also. So mainly these are the some properties of ROC. Okay. So and regarding of ROC, few things. Okay. See, x of n. For example, do another problem. 1, 2, 3, 4. This is the in time domain, and this is x of n is equal to u of n. So uh, another point, that is z transform. The value of z transform should be finite, not infinite. Finite. So this is a finite values. So then x of n u of n, then 0 to 4, n equals 0 to 4. So what is the z transform of this? So this is x of 0. Some you expand this and like this, and 3 plus 2 by z. So this is the z transform. Okay. So x of z is equal to infinity at z equal to 0. Z equal to 0. The x of z is infinity. But what is first point primary thing? The value of z transform is finite. So that this is infinite at z equal to 0, and this is 3. This is 3 at z equal to infinity. Just put infinity instead of z, we get only 3. That means what is the conclusion of what is ROCS is entire z plane except 0. ROC is nothing but entire z plane except z equal to 0. Where z equal to 0, x of z is does not exist. At z equal to 0, x of z does not exist. So entire z plane except z equal to 0. See this. Another thing is right side problem. X of n equal to 0.5 power n u of n. So that x of z is equal to minus infinity to infinity x of n z power minus n. So you put it a substitute in the formula 0.5 power n z power minus n, and you always try to make them as a power n. Already I have told that. So 0.5 z power minus n a power n. So 1 by 1 minus a z by z minus 0.5. So that you observe that what is the radius of this circle? 0.5. So you draw the circle with 0.5. What you came to notice that is the problem is multiply with u of n. That means the sequence is u of n. That means right side sequence. So that means outside of the circle. Outside of the circle. This is the so ROC. See, ROC you just write like this. X of z is converges for all points outside of the circle. Okay. You do some problems like this. See. 1, 2, 3, 1. So x of z is equal to n equal minus 3 to 0, x of n z power minus n, and this is the formulas. And x of z is 1 is valid. Z equal 0, we get the value 1, and z equal to infinity, infinity. So that means where we get the infinity, that is does not exist. That means does not exist. So what is ROC? Entire z plane except z equal to infinity. Okay. So what about this right side? See this. These are the infinite some x of n is equal to 0.8 power n u of minus n minus 1. That means the sequence is left side sequence. That means already before solving the z transform, we came to notice that this is ROC of z transform is inside of the circle. By using the properties, you know that inside of the circle, but you don't know the thing is what is the radius of the circle. See, apply the z transform formula x of n z power minus n and 0.8 power n and z power minus n, and we get the z by z minus 8. So this is radius of the circle, and x of z is converges for all points of inside of the circle. See this. If you have any doubt, please put in comment section. I will make sure uh, solve it. See, and pause it and solve these problems. You know, as earlier I explained this 0.5 power n u of n plus 0.8 power n u of minus n minus 1. See this, this is the right side sequence, this is the left side sequence, This is right side sequence means outside of the circle with a circle 0.5, and this is 0.8 with circle of 0.8 radius. This is the inside of the circle. So when we both crosses, you just shaded outside of the circle entire of the jet plane, here inside of the circle entire the jet plane, but where it is crossed, that is called a convergence. So the region of convergence of jet transform, so he just finally concluded x of z is a convergence in between two circles, converges in between two circles. You just note down that. Okay, so this is a jet plane. Okay, this is imaginary line, this is a real line. Yeah, I forgot to say that in Laplace transform, what how can you represent the ROC means left side, this is the S plane, and left sided and right sided shaded, so like that. But here in jet transform we are using unit circle, instead of we are using a S plane, we are using unit circle. Okay, so this is all about and what is the properties. These are the some properties I'm explaining. uh, these are properties one by one, but only two properties I explained. So this is a linear property, this is a shifting property. See this, what is shifting property? Shifting property of jet transform states that jet transform of shifted by m units of the time obtained by multiplying jet power m to jet transform of the unshifted signal. So this is called a jet transform. See, to prove what is the statement means, jet transform of x of n is equal to x of z. Okay, and x of n minus m is equal to z power minus m x of z. Okay, so let's prove this formula whether it is okay or not. Z of n minus m is equal to z power minus m x of z. So this is to prove, and let's start a proof. X of n, z transform of x of n is equal to x of z, and z transform of x of n is equal to n equal to minus infinity infinity x of n z power minus n. So z of, okay, this is right side, it is a n of n plus m, so see only n minus m. Okay, this is z transform of x of n minus m is equal to n equal to minus infinity into x of n minus m z power minus m. So this is the but uh, n minus m is replaced with the p, n equal to p plus m. So when n equal to minus infinity, p equal to minus infinity, or n equal to plus infinity, p equal to plus infinity. See what happened, x of p is equal to z power minus p plus m. So z power minus p, z power minus m, z power minus m, just keep it aside, and it look like say x of z again. So this is the shifting property, and you should know one thing, that is it's very important formula. If x of n minus 1 delayed version, x of n minus z transform of x of n m is what is the z transform, z power minus m x of z, z x of n minus 2 z power minus 2 x of z, n minus 3 z power minus 3 x of z. So like this. So these are the some properties, and every properties are available in my notes, and I will forward in Google Classroom. So already uploaded, you just download it and study it. So these are all about jet transfer. Just and see some problems in signals and system nodes. So these are some properties. Okay, so yeah, initial theorem and final theorem also very important. The initial value theorem of jet transform state that for a causal signal x of n, jet transform x of z, x of 0 is equal to limit tends to in infinity, z tends to infinity x of z. Okay, so what is the how can it is proved? See, jet transform of x of n is equal to x of z is equal to n equal to infinity to n equal to 0 to infinity x of n z power minus n is equal to x of 0 plus x of n, x of 1 z power minus 1, x of 2 z power minus 2, and again you just normalize x of 0 plus x of 1 by 2 plus x of 2 apply z square, taking the limit both sides z to infinity, and both sides limit z tends to infinity x of z, limit z tends to infinity x of 0, and everything will become like a 0, because if you replace z with the infinity, every values are become like zeros. Finally we got uh, limit z tends to infinity x of z uh, is equal to x of 0. So this is initial theorem. So hence it proved as a limit z tends to infinity x of z is equal to x of 0. This theorem helps us to find out for the initial value of x of n from x of z without taking its inverse z transform. Okay, so we can easily find out the initial values. Okay, final value theorem. Final value theorem means also that x of n z times x of z, x of infinity is equal to limit tends to limit z tends to 1 z minus 1 x of z. See, if actually in Laplace transfer in before classes limit z tends to 0, but here we are using z tends to 1, because why we are not using z equal to 0 from z equal to 0 means z equal to 0 means radius equal to 0. Radius equal to 0 means the circle will become like a point circle. So how can you observe that? So that the reason we move for 1. That is the reason we consider a unit circle while drawing ROs. So z limit z tends to 1 z minus 1 x of z. Okay, so you just pause it, and you can solve this problem. Okay, proof. So finally we got x of infinity limit z tends to 1 z minus 1 into x of z. So problem C, a power n cos n omega n u of n. So what is the z transform for this function? This is in time domain or n domain. So let's convert them into frequency domain by using z transform. Well, you know the formula, x of n is equal to minus infinity to infinity x of n z power minus n. And also, as we are earlier we discussed that we always try to make them as a power n, so that first of all we convert them into exponential format cos n omega n. So this is a power n into e power j n omega plus e power j n omega by 2 z power minus n. So like this, and after that a power n e power j n omega n j power minus n, and n equals 0 to infinity a power n e power minus j n omega j power minus n, and you just take a common n in both sequences. It becomes like a power n. It's look like a power n. Then immediately, what is the formula for that? 1 by 1 minus a, 1 by 1 minus a. So that after a lot of normalizations, you get finally x of z is equal this expression. This is about how we solve the z transform for sinusoidal signals. See all problems. So you can find you can solve by using your respective textbook or my notebook. So this is all about z transform. See, this is one of problem. Find the This is a finite sequence defined as x of n. So there are a few types of problems. Type 1 problem is nothing but sequence type, and type 2 problems is x of n is equal to n into e power n, like this. So first, sequence type problems, if we consider sequence type of problems, you see one or two examples. This is a sequence type. X of n is equal to 5 3 minus 3 0 4 minus 2. So what, there is no arrow mark. So then we put it a arrow mark in a initial value x of n. X of 0 value is 5, x of 1 value 3. So like this. So what is the z transform formula? X of z is equal to n equal to minus infinity infinity x of n z power minus n. So 0 to 5. Okay, there is a 0 to 5, 0 to 5. So 0 to 5 x of n z power minus n. So expand them, and after that, what is x of 0 value is 5. X of 0 value is 5, and z power 0 is I think 1. So 5 plus x of 1 value is 3 and z power minus 1. So 3 into z power minus 1. So this is x of z totally. And if sometimes we need to convert, find out the inverse z transform, if they give in z domain, if this is a problem z domain, you simply convert like a in time domain 5 3 minus 3 4 minus 2. Okay. After this, these are the some problems. Pause it and solve it. These are the some sequence type of problems. So find the signal x of n. See, here asking inverse problem. You know the formula for inverse formula. Already you know that. What is the inverse formula of z transform? Z inverse x of z is equal to x of n 1 by 2 pi j x of z z power minus z power n minus 1. Already we derivated in previous. Simple, x of z is 4 z power minus 4 z minus z cube 0 3 z square. So there is no value for 0, so put it 0 per z square. 4 3 2 1 0 minus 1 minus 2, so like this, x minus 4 x minus 3 x minus 2 x minus 1 x, like this. So finally you remove the coefficients and that treated as a n domain values, 4 minus 1 0 3 0 4 3. So this is inverse. Okay, and type 2 problems like x of n is equal to n into a power n minus 1, x of n equal to n minus 3. So pause it and solve it, try to solve it, it's very simple. Okay, and type 3 problems is sinusoidal, already I told about, like. And type 4 problem is combination of exponential and cos omega t problem. Sir, these are the and type 5 problems is nothing but initial value and final value theorem problems. So these are the main 5 problems. See some initial value theorem problems also. So x of z is equal 1 by 1 minus z. Find the initial value. That means what is the initial value theorem? Limit z tends to infinity x of z. So 1 by 1 minus z in power minus 2 is equal to limit tends to z power z tends to infinity 1 by 1 minus 1 by z is equal to 1 by 1 minus 8. So we got the value like 1. So this is the initial value. What is the final value there? This is a 1 by 2. So without solving anything, we easily find out the initial value and final value by using theorems. So let's start inverse jet transform. See, inverse jet transform to the process of finding x of n. Up to now, we discussed about jet transform and how can we solve the jet transform. There are 5 types of problems also we discussed actually. See, the process of finding x of n from its jet transform x of z is called a inverse jet transform. Inverse jet transform can by following 3 methods. There are like long division method, and the second one is a partial fraction method and a residue method. These are the 3 methods. By using 3 methods we can solve the inverse jet transform. Okay, how can we find out by inverse jet transform? So the given problem is in jet domain. So using partial fraction, let's see solve the problem. And if it is time domain, we are going to find out jet transform and ROC. But if you want to find out time domain from the jet domain, they are already given ROC also. That means modulus z less than 2. That means inside of the circuit. That means left side sequence. The given sequence is left side sequence. That means, so what is the how can you find out the inverse or find out the n domain from the jet transform by using a partial fraction method? We have 3 methods: long division method, partial fraction method, and residue method. But now I am discussing about partial fraction method. So x of z is equal to 2z minus 7 by z square minus 5z plus 6. ROC is z less than 2. So to solve the partial fraction method, so divide both with the z. So x of z by z here also. So 2z minus 7 z into z square minus 5z plus 6. 2z minus 7 z into z power minus 2 z minus 3. Here a by z. You have to partial fraction type, you just expand them in, and a into z into x of z by z, where z equals 0. So that x of z by z equation is this is. So you just replace this equation with replace x of z by z with the 2z minus 1 7 into z into z square minus 5z plus 6, or you just keep this equation z equals 0 is equal to minus 7 by 6. So this is, you just pause it and observe. So finally we got value like x of z is equal to minus 7 6 minus 7 6 plus 3 by 2 z by z minus 2 minus 1 by 3 z by z minus 3. You know formula, z by z minus means u of n. That means unit step. But one thing, you cannot put u of n because this is a left side sequence. That's the reason u of minus n minus 1. Here this is 1 means del of n. This is z minus z by 3. Again u of minus n minus 1. This is the total time domain signal. This is x of z inverse. So how it is? Same partial fraction method. Let's see. Pause it and solve it. And after that, find the ROC. Find the jet transform and ROC. See, they're given in the form of time domain. So x of n z power minus n and u of n z power minus n. See, simply pause it and solve this problem. So let's start to find out ROC. Already I have told that ROC, to find the ROC, you observe the problem. This is x of n z power minus n. The given problem observe, this is multiplying with unit step u of n, right side sequence. That means it's sure that both circles, the ROC is outside of the circle. So that by using that concept, but we don't know the radius. So z equal to 5 by 7, z equal to minus 1 by 3. So these are the two circles. Let's draw the two circles with the two radius. Both are in outside of the circle. So finally, what is the ROC? So that ROC is nothing but between two circles. Okay, so ROC is between two circles. Find the jet transform following convolution property. So see, these are the some problems. Okay, next, see long division method. By what is using final theorem, find out the heads of z. Okay, so z transform, these are all. So prove that, show that like inverse z transform. See, find out the inverse z transform. E power z plus e power 1 by z. From exponential series or Taylor series, you can expand e power z plus e power 1 by z, 1 plus z, like this. And after that, simply you know that just remove the coefficients from the z, that is called nothing but a x of n. So another problem, log base 10 1 plus a power z. So log base 10, there is a formula right side, log base 10, log x base 10 is nothing but log x base e and log 10 base e. So this is the formula for expanding log x base 10. Log e 1 plus a z inverse and log e 10. So you just put it a common and expand them like this, and finally we got the answer like this. So that, so everything just pause it and solve the problems. So that x of z, here also x of z is given and solve it. These are all our series method, as are like type 1, type 2, type 2. See this long division method. See long division method, now up to now we discussed like a partial fraction method. Now long division method, how can you find out the inverse? We have three methods. One is a long division method and partial fraction method and residue method. So partial fraction method already I have completed. So now we go for long division method. How can you find out the inverse z transform? So there is a problem, x of z is equal to z square plus 2z by z cube minus 3z square plus 4z plus 1. ROC is z greater than z greater than 1. See, ROC is must only given in the problem to find the inverse. If it is in z domain, so definitely they give ROC also. If it is n domain, you have to find out the z transform at the same time ROC also. But already it is in z transform means there is a ROC also. By using ROC, you can decide the circle, inside of the circle or left side sequence or outside of the sequence. That is the use of ROC. Z greater than 1 means that is outside of the circle. That means right side sequence. That means you just multiply u of n. U of n. That is the meaning of the problem. So how can you solve this? Long division method is very simple, but one thing you should know that if it is z greater than a, that means ROC is greater than 1, then powers of z descending order. If z less than a or z less than 1 ROC, then ascending order. The powers of z should be ascending order. See here greater than 1, so that powers of z transform z is descending order. All values are in descending order. Luckily, fortunately, the given problem is in descending order. If it is not in the it like that, you mustly make it them like a descending order. So solve it. So how can you solve this? So see, you just numerator is like this and denominator like this. So z cube minus 3z square plus 4z plus 1 and z square plus 2z. So one thing you should know that how can we get z square value? By what value we have to multiply with z cube? So that you should understand that z cube into z square, then we got a z cube into z power minus 1, we got z square, right? So see this. So how can we get z square only? So you forget about these values. Only how can we get z square? That means you have to multiply this z cube with z power minus 1, we get z square. So that we are we get z square. After that you have to multiply this entire sequence with z power minus 1. So minus 3 z square into z power minus 1. See what happens. Z power minus 1 into 3 into z square, nothing but 3 into z power minus 1. See this, z power 2 into z power minus 1 becomes like a 3z minus, and plus 4 into z square into 4z power into 4 z power minus 1 is nothing but 4, and plus 1 into z power minus 1 is nothing but z power minus 1. So this is the entire value, and after that you just cancel it and we got 5z minus 4 minus z power minus 1. Again you do one thing, that is, so for what value we get 4z, for what value we get 5z. See this. So what it is meaning? See, z cube into 5z power minus 2. So by multiplying z cube with 5 into z power minus 2, we get, so we don't know. First of all, I don't know this value actually. So how can you get? So I'm trying to cancel this 5z by multiplying some x value. So you have to multiply x value with z cube, then we got 5z, and I'm trying to cancel each and every. So that I came to know that if I multiply with 5 into z power minus 2, I got 5z. So that like that, and after that you just multiply 5z power minus 2 with the entire sequence, entire value, we get same value like this. This is. So after that cancel, and 11 minus 21 into z power minus 1 minus 5 z power minus 2. After that we don't know this value also. We don't know first the, and no, and this is also we don't know. I want to cancel 11. How can you cancel this 11? So that how can you get this value? For example, there is 11, here also 11, then what is the value here comes? If what value we have to multiply with, means that means you have to divide this value. So 5 in 11 into z power minus 3. Okay, see that value is right or not. So this is 11 into z power minus 3. So you have to multiply the entire 11 into z power minus 3 with a entire sequence, this sequence. So we got like this. So similarly, so do everything. Okay, so up to it is we cannot decide up to 0 or anything. So you just sometimes they are asking 5 steps or 4 steps or like this. So this is the answer, and so on. So what is, see finally what is answer? That means z power minus 1, z power minus 1, z power minus 2. See, we could remove the coefficients 0, 1, 5, 11. So this is the, and now finally residue method. See, residue method is nothing but by explaining this derivation it's difficult to understand, but by solving the problems you will understand clearly. Inverse Z transform of x of z can be obtained by using the sequence x of n is equal to 1 by 2 pi j x of z z power minus, it is like a uh, integral, circular integral. This is called x of z z power minus n minus 1 dz. So x of n is equal to summation of residue of x of z z power n minus 1 at the pole of inside the C. So what is the meaning of that? Means z. So this is the formula. Summation of I equal to z minus zi x of z power n minus 1 at z equal to zi. This is the residue method. See, very simple actually the problem. See, find the inverse using residue method. Already I have told that to solve the inverse method, to solve the inverse Z transform, we have three methods. One is a long division method, one is a partial fraction method, and another one is a residue method. So this is residue method. See what is how it is. 3 plus 2 power 2 into z power minus 1 plus z power minus 2, 1 minus 3 z minus 1 plus 2 into z power minus 2. So just rearrange like this and rearrange like this, and okay. So the and next you just 3 see x of z equal to 3 plus 11 z minus 5 z minus 2 and z minus 2. We just characterize it like this, and x of 1 of z3 and x of n z power minus n x of 2 and z power minus x of sorry z of 3 3 into del of n. So this is x of 1, okay. So x2 of z. See, means you are applying inverse Z transform for this sequence and this sequence. Already I can find out 3, and now we go for this expression. This expression I am going to do the problem. So simply see x of n, Z inverse of 3 and Z inverse of x2 of z. We know Z inverse of 3 is nothing but 3 into del of n. And what about this? So what is the formula for that? I into 1 to n z minus pi x2 of z by into z power n minus 1 at z equal to pi. See, yeah, how can you find out? So z minus 1, pi means poles. We are nothing but pi nothing means number of poles. There are two poles only, p1 and p2. So first pole z minus 1. So 11 z minus 5 by z minus 2 and z minus 2 into z power n minus 1, and where z equal to pi means first pole z equal to 1. So you can find out. So at the same time plus second pole z minus 2 into that entire expression into z power n minus 1, and where z equal to, okay. Yeah, next to just next come to next. So you just pause it and observe, you could understand. So finally we get the values like this. So x of n is equal to 3 del of n 6 into u of n minus 1 plus 7 2 in power n minus 1 u of n minus 1. See, uh, and 3 into r of n del of n. So finally if you put the n values n equal to 0, x of n value becomes like a 3, and n value equal 1, x of n value like a 11. If you put a 0 2 value, we get a like this. So this is like residue method, and this is example for partial fraction method. See, one pause it and solve it. See this, okay. It's very simple. Inverse method, okay. So see, I want to explain ROC of this expression. See, ROC, what already they given ROC, right? Find the inverse and find ROC. You can do any with long division method or residue method or whatever you want. Z greater than 2 and Z less than. So find the Z transform for ROC. If ROC is greater than 1, 1 is one of the problem. Find the inverse Z transform for ROC Z less than 1. If ROC 1 less than 1 less than Z less than 2, then what is the inverse? So there are three type of problems. You can give, you need to give the three type of answers, okay. So that commonly one thing, you just do the problems like here partial fraction method I am doing this. So finally we get the answer. So okay, note that if it is if ROS is greater than 2, then what means right side of the sequence. So finally what is the actual, what type of answer we get? See this, we got minus 3 z by z minus 1 plus 3 z minus z by 2. So first problem answer, what is the answer? if ROC is z greater than 2, that means right side sequence. See, put it like this and draw the ROC also. If it is ROC z less than 1, that means u of n minus 1 and 3 into 2 power n u of n minus 1. So this is the second answer. Okay, antical. If it has a middle both circle, see this u of n and u of n minus u of n minus n minus 1. This is the inside of the circle. So this is the one. And I don't want to discuss about convolution method. These three methods are important. So I think you will understand. I hope you are understand. See, there are plenty of problems. Solve it. So these are the entire concept of jet transform. Okay, partial fraction method. Solve it these problems by using this. Pause it and solve it using partial fraction method. So I think better to choose a partial fraction method. It's very easy to us. See, you should know that right side sequence are inside the circle or outside of the circle. See, okay, you should observe that. Yeah, this is all about jet transform. Okay, so I think it's everything is over. So residue method. This book actually there are two notebooks: digital signal processing handwriting notes and signals and system notes. So, but both are same. So, so everything is okay. Partial fraction methods. Do any one of the problem, just practice it. So long division method has a one rule is nothing but descending order or ascending order, that based on depends upon ROC. If ROC is greater than 2 1 or anything, that means right side sequence, then you should maintain the powers of Z in descending order. Okay, but there is no rule for residue or anything. So partial fractions. Find the inverse jet transform. See, already in the previous class I explained. See this, everything is fine. Okay. So convolution method. So like this. So this is all about jet transform. If you have any doubts, and I completely uploaded my notes to Google Classroom. Okay. So next class I will explain system realization. Thank you.